Adding and removing of elements used to take place at the only one point called top point or top pointer. New elements are added at one end called rear end. That is the rear end, or the rear pointer is the one where new elements are added into a queue. Whoever gives the print command first, he will be the one to get the chance to get the printout first, and other request will be in a queue. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our discussion with the chapter Q. Now, in this session, we are going to talk about the Q, introduction to Q, and operations on Q. These are the topics to be discussed in this session. Let us start with introduction. So, what is a queue? What is a queue? So, queue is a data structure. You have learned in the previous chapter the definition of data structure and example for data structure. So, what is a data structure? Data structure is a processing, or it is a system where we can store the data and we can organize the data, and it will be easily accessible by the user. That is the definition of data structure. And we have learned as an example stack and queue. Stack and queue are the example for data structure. In the previous chapter, we had discussed about stack. Now let us discuss about one more data structure, queue. So queue is a data structure which works on the first in, first out principle. So that is the definition of queue here. So if you remember, stack works with the principle of LIFO, last in, first out principle, but queue is a data structure. It works with the principle of FIFO. The full form is first in, first out. So it is an ordered linear list. So as we are implementing a stack and queue in Python using a list data type. So QA is an ordered linear data list of elements having different ends for adding and removing elements in it. So one of the properties is observed here. So here it is adding and removing at two different ends, not at the same end. Now if you compare this with the stack, stack is a data structure where the insertion or deletion or adding and removing of elements used to take place at the only one point called top point or top pointer. But here in Q is a data structure where addition and deletion or removing of elements in a list takes place at two different end or two different pointer. So what is the meaning of FIFO, first in, first out principle? Here, since the element entering the first in the queue will be the first one to come out of it. So that is the meaning of first in, first out. So any element or any data entering into the list, entering into the queue, mean the first element entering into the queue, the same element will come out of the queue. So here first element inserted will be the first element removed or to be deleted. That is the principle of first in, first out. Now let us see some example in our real life. The customers forming a queue at the cash counter in a bank. See, it is a common examples. So whenever you go to any bank, any of the billing counter or any counter in a bank, all the customers, the clients will be standing in a queue. That is a real-time example for queue data structure. So here, whoever in the queue, the first person in the queue will be the one to be attended. So that is the principle of FIFO. And another example is vehicles queued at the fuel pump or at petrol pumps. And again, people in a ticket counter. See, these are the things we have come across in our day-to-day life. These are all simple examples for queue. That is a queue data structure. So if you observe this, anyone who is at the counter, the ticket counter, will be the one to come out of the queue. So that is the concept of first in, first out. Now let us see about the data structure queue. So what is a queue? It is an arrangement in which new objects or items always get added at the one end and usually called as rear end. and the objects or item always get removed from the another end called front end. See, this is what you have seen in the definition of the queue. See, where addition and deletion takes place at two different points. So accordingly, the new elements are added at one end called rear end. That is the rear end, or the rear pointer is the one where new elements are added into a queue. And similarly, the elements removed at the pointer called front. So front is the point or the pointer where the removal of elements takes place in a queue. So there are 2 points, rear and front point. Rear is another name is called tail end and front is called as head end. So here this is the definition of data structure. Queue is a data structure where addition takes place at the one point called rear point or rear pointer, and deletion or removal takes place from another point called front point or front pointer. So another name of rear is tail and another name of front is head. Now look at the example here. See, this is how we represent a queue in the list. So if you observe this, see, these are the elements 3, 4, 5, 6, 7, 8 are the elements of a queue or elements in a data structure queue. So here this is called a rear pointer and this is the front pointer. So if at all if you want to add one more element, so this is the place we want to add one more element at this point. For example, if I want to add 9, so 9 will be added at the rear pointer. And similarly, so that is another name is called NQ. And suppose I want to remove the element or deletion or deleting element from the queue takes place at the front point or front pointer. In this example, 2 is the element to remove first. Earlier 2 will be here, it was the position of a 2. If I want to delete the element, so 2 is the first element inserted that has to come out. That is the concept of first in, first out principle. In this example, these elements, another name is tail or rear end, front or head end. So this is the place where insertion takes place. Another name is called NQ. Operation is called NQ, and here the DQ is another end. It is the removal takes place at this pointer. So this is the data structure queue. Now look at another example here of a data structure queue. Here is, if you observe this, HELLO, and this is the one. These are all the elements of a queue data structure, and 0, 1, 2, 3, 4, 5, and this is the rear pointer. So where we can add new element into the queue, and this is a front pointer. So element to be removed is first element, that is front element. So if at all any deletion takes place, only takes place the front end. In this example, H has to come out of the queue or H has to come out of the queue. That is the meaning of first in, first out principle. And always if I want to add one more element to it, and the rear is a pointer, so I can add one more element to this pointer. It is called rear pointer. So this is the example for data structure queue. Now let us see what are all different applications of a queue. It is now train ticket booking system and lists such as waiting list. This is another example. You might have come across in your day-to-day life. Whenever you book a railway ticket through online or maybe at the ticket counter, if at all if there are no seats vacant, or if there are no vacant seats are available, then you will get a number that's called waiting list. So the waiting list is an example for one of the applications of queue. Next one is sometimes calling a customer service center, the IVRS system or interactive voice response system. So this is also a very example for queue data structure, example for queue. See, whenever the customer calling that particular number, he will get the chance or he will be attended first, and any calls comes later to it, it will be in a queue. That is the example for IVRS, an example for applications of queue. And one more example is single lane one-way road. It is also another example. Vehicle following the concept of queue. If there is only one way, What is the meaning of this? If there is only one-way traffic, if the road is marked as one way, then all the vehicles follow one by one following other. That is an example for queue. These are the applications or example for queue data structure. In the next slide, other applications are a web server can handle maximum of 50 concurrent requests to view the results. So, to serve thousands of user requests, a queue would be the most appropriate data structure to use. Now, you are familiar with this web browser or web server. So, it is also an example for our applications of queue. And here, some operating system, OS, required to handle multiple tasks called jobs seeking to use the processor. So here, this is multitasking system in operating system or multi-programming system. All are example for queue data structure. Here, whichever the task or whichever the jobs which send the request for execution, those jobs will get the preference and others will be in a queue. It is also an example for queue, and it is the one of the function of operating system. Next one is when we send a print command to the operating system, these print request in a queue and sends them to the printer one by one on the FIFO basis. This is also a very good example for printer queue. For example, generally small office scenario, generally they will be having only one printer and maybe more than 10 computers. So all the 10 computers will be making use of only one printer, and whoever gives the print command first, he will be the one to get the chance to get the printout first, and other request will be in a queue. It is also a very good example for queue data structure. In the next slide, we will see what are all different operations can perform on queue. So, what we have seen in the previous chapter about stack, we have learned the different operations on stack. We have like a push, pop, and similarly, even in queue is a data structure. We can have or we can perform different operations on a queue data structure. So, here following are the few functions to be or operations can be performed on queue. First one is NQ. NQ is used to insert a new element to the queue at the rear end. So, NQ is one of the operation. It is used to insert a new element at the rear end because the insertion and deletion takes place at two different ends in a data structure queue. Insertion takes place at the rear end or rear pointer. Now, next one is DQ is the operation. So, what is DQ? DQ is used to remove one element from at a time from the front of the queue, because in the front is the pointer where the deletion takes place. So, a DQ is nothing but it is a deletion of another name is a deletion operation, and deletion operation takes place at the front end. Is empty. Is empty, it is used to check whether the queue has any elements or not. Whether to find out whether the queue is empty or not, we are using is empty is one of the operation. Next one is peak function or peak operation. What is the definition of this? It is used to view the elements at the front of the queue without removing it from the queue. And here, please understand that. So, peak is the function. It is a function or an operation. It only we can view or display the element at the front point or nothing but the first element which has inserted. It is going to display it, but without deleting or without removing the element from the queue. Next one is full. So, here is empty. Next one is full. It is an operation or a function to check whether any more elements can be added to the queue or not. Here, in other words, we can say whether to check whether the queue data structure is full or not. If it is full, we cannot add any more new element into the data structure queue. So, this is full is one of the operations on queue. Now, let us see with this diagram the different operations like NQ and DQ with this diagram. Now, let us see the operations performed. These are the operations and what is the status after the operation. So if you look into the first one is NQZ. See, at the beginning it was the Q data structure is empty. There are no more elements. So first operation is NQZ. NQ is an operation to insert new element at the rear end. So here NQZ, we are going to add Z element into the data structure Q. This is the rear pointer, this is the front pointer. Second operation is NQX. So next element, so because this is a rear pointer, so addition takes place at this pointer. X is a new element which is added at the rear pointer. This is NQ operation. Similarly, NQC. C is we are adding one more element at the rear point here. So now elements are Z, X, C. Please observe this. The Z is the first element inserted, and this is the second element, and this is the third element inserted. The next operation is NQ operation. So whenever we are using NQ operation, here there are no more elements added here, just we are using NQ operation or a function. It takes out the first element from the Q, that is Z will be removed from this point because of this NQ function. Next function is, operation is NQV. So we are going to add one more element V at the rear point. Now the elements are X, C, V, and Z has been removed because of this NQ function. Next one is DQ function, and here DQ is nothing but deletion of elements from the data structure Q, and it is going to remove the first element which has been inserted. In this example, now at this stage we are left with the elements X, C, V. Because of DQ function is going to take out X outside the structure. So we are left with C and V here. So here we have one more element V. Next one is, after we have one more DQ operation. So after this, in this stage we have only two elements C and V. So because of this operation, this C will be eliminated. We are left with only variable or one element V. See, these are all the different operations can be performed. So here one is NQ, one more is DQ. NQ is to add new element at the rear end. DQ is a operation, a function to remove the element at the front pointer, or in other words, the element which has been inserted first in a data structure Q. Students, so far in this session, we have learned the definition of data structure and definition of a queue, and what are different operations can be performed on queue. Let us continue our discussion in my next session. Thank you very much.